Good morning, dear students. I, Rajesh Kumar, your physics teacher. Today, we will study chapter 2, units and measurement, and we will study this chapter in four parts. Four parts will be as units and measurement, then errors and its types, dimensional analysis, numerical based on the concepts. Okay, in this particular video we will study only about units and their measurement. What are the basic units, how the measurement is done, as well as some methods of measurements also we will study. Okay, let's proceed. Units and measurement. Before going to that, we will study about physical quantities and the characteristics also. Okay, physical quantities which can be measured directly or indirectly, and in terms of which physical laws can be expressed, are called physical quantities. For example, mass, length and time are some physical quantities. And unit, we will move to next definition. Unit is in the process of measurement the standard chosen or opted which is of same kind as that the physical quantity is called unit. Okay, the size of physical quantity will depend upon the size of unit, number of times the unit is repeated, and okay, the size of the physical quantity will be denoted by capital Q, and it will be equal to the size of the unit U into number of times the unit is repeated, that is Q is equal to N U. Okay, which should remain constant whatever the units will be chosen for that. So Q will be equal to N1 U1 for one type of physical quantity, and is equal to Q N2 U2 for the other type of physical quantity, or for other units of the same physical quantity also. So N is inversely proportional to 1 by U, or U is inversely proportional to 1 by N. That means the size of the unit in a physical quantity is inversely proportional to the number of times the unit is repeated. Okay, if more will be the number of repetition for the units, then its size will be smaller. Okay, because they are inversely proportional to each other. Now the characteristics of a unit chosen will be, or what will be the ideal characteristics for a particular unit being to be selected. The unit should be well defined. There should be no confusion in defining the units. It should be universally accepted. The important thing, it should be accepted everywhere, not at a particular place. It will not be valid at a particular place only. Okay, it is worldwide accepted. It should be easily reproducible. We can easily convert it into one form to another form, can be reproduced easily. Okay, it should not change with the physical conditions like temperature, pressure, moisture, heat. Okay, it will remain same. Got it? In this particular slide we studied about how many parameters? Physical quantity, definition of unit, size of physical quantity, as well as some characteristics of the physical quantity. Okay, Other characteristics is it should not change place to place. We already discussed, I think, this. It is worldwide accepted. Types of units. In this particular slide we will discuss. There are two main types of unit. One is fundamental, other is derived. Okay, fundamental units which can neither derived from one form to other units, or those can be resolved into other units, are called fundamental units. Okay, the unit of fundamental physical quantity is also called fundamental unit. Okay, basic units we can call them. They do not need any derivation for their description, that's why we call them fundamental or basic units. Mass is having basic units kilogram, length is having meter, and time is having seconds. Okay, okay. Now this we can also remember by this: m meter, k for kilogram, and s for seconds, time for time. Okay, so it is mks, meter, kilogram, seconds. Okay, derived units which can be expressed in terms of fundamental units are called derived units. For example, force, pressure, okay, work, energy, whose fundamental units are kilogram, meter, and seconds. Okay, for example, velocity, it is having mass meter per second, having units meter per second. System of units, the set of fundamental and derived physical quantities is called the system of units. Set of unit of fundamental and derived, when we consider both type of units simultaneously, then it becomes the system, and it is collectively known as system of units. CGS system. Now we will study about different types of earlier existing system of units. System of unit in which the unit of length is centimeter, mass is measured in gram, and time is measured in seconds. Whatever will be the system of units we will consider, the unit of time will remain, it is second. Okay, let's move further. MKS system of units. The system of unit in which the length is measured in meter, mass in kilogram, and time in seconds. This I already discussed with you earlier also. FPS, the system in which length is measured in foot, mass in pounds, and time in seconds. FPS, foot, pound, and seconds. Now, these were earlier existing system of units, and they can vary from place to place, okay, or country to country. Now SI, international system of units, to remove the differences, to remove the confusions, a system of units was opted, that is known as international system of units. It is worldwide accepted. This system of unit is having 7 fundamental units and 2 supplementary units. Okay, then fundamental units: mass kilogram, unit is there, length meter, time seconds, temperature Kelvin, current ampere, luminous intensity candela CD it is denoted by, and quantity of matter, it is mole, measured in mole, MOLE. The symbol is mole, MOL. Supplementary units are there, 2 supplementary units we will study about them. Angle, plane angle we can call it, the amount of revolution of a line or radius vector from its initial position is called the angle, and it is denoted by theta. You can see in the diagram also, a circle is drawn having center O, radius R. Okay, A is the initial position, B is the final position along the radius. Arc AB is equal to, it is, if we consider it AB equal to L, then theta will be equal to arc upon radius AB upon R is equal to L by R. The unit is radian. Okay, now let's move to the next unit. Solid angle. Solid angle, it is the angle in 3 dimensions denoted by omega equal to dA upon r square. You can again see in the diagram also, circle is given there. R is the radius, W or omega is the symbol of solid angle, and there you can see the dA is the small area element. Okay, then the solid angle is equal to omega equal to dA upon r square, and its unit is steradian. Okay, got it? Let's move further. Now we will study about coherent system of units. A system of unit is said to be coherent if we obtain all derived unit either by multiplying or by dividing the fundamental units and the system without introducing any numerical factors. Okay, got it? Coherent means same type of units. Advantages of SI units: it is a coherent system of unit, it is a rational system of unit of energy for all form, and the SI unit is only joule. Okay, system is metric system of unit. It is an absolute system of units. No gravitational units are there. The use of G is eliminated in this particular system, and it is closely related to MKS system and CGS system also. So in this particular slide, what we study about solid angle coherent system of units, as well as advantage of SI system of units. Okay, now move forward. Light year, we will study about some methods or some other units. Those are used for the measurement of long distances. Light year is the distance covered by the light in 1 year is called light year, and its value is equal to, it is denoted by 1 Ly is equal to 9.46 into 10 to the power 15 meter. Normally this unit is used for measuring longer distances. S is equal to C, we all know C is equal to speed of light, distance is equal to S C into T, speed of light into time 365.14 1 by 4. Okay, into number of days, this is, it will is converted into seconds. Then the unit or the value of 1 light year comes 9.5 into 10 to the power 15 meter. Astronomical unit, the distance between the center of the sun and the center of earth is called astronomical unit, and it is denoted by AU, and 1 AU is equal to 1.5 into 10 to the power 11 meter. Okay, now parallelic seconds or parsec, 1 parsec, it is the distance at which an arc of one astronomical unit subtends an angle. Subtend means make an angle of 1 second. You can see 1 parsec is equal to theta, we all know it is L by R. R is equal to L upon theta. 1 parsec is equal to 1 AU upon 1 second, and see the values conversion. 1 astronomical unit we already discussed upon 1 second, it is, you can find out 1 by 60 into pi upon 80, 1 by 60 into 60 into pi upon 80. When we solve this, then the value will be 3.8 into 10 to the power 16 meter. Okay, now let's study some relationship also between these distances units. 1 light year and parsec, it is equal to 1 parsec is equal to, after putting the values over there, then it is 3.26 light year. Light year and astronomical units, again you can see the relationship 1 ly upon 1 l and u. It is 1 light year is equal to 6.3 into 10 to the power 4 astronomical units. And now we will study about the last methods for this particular class, parallax method. This method is used to find the distance of stars which are not very far away. Observe the nearby star O from the position A with respect to fixed star X, and note the theta 1 after 6 months from the position B. 6 months from the position B, note the position of theta. So you need to measure the same positions or observe same positions few months back, and again then the angle made will be AOB. Try to observe the same star from the two different positions. Angle theta 1 is the from position A, and angle theta 2 from position B. It is angle AOB is equal to theta 1 plus theta 2 is equal to theta, and as theta is equal to arc upon radius, now the arc will be again AB, okay, and theta is very small, so theta is equal to AB upon OA, equal to AB upon OA, okay, got it? So you can easily measure the distance OA. Similarly, you can also measure it is OB. Same will be the distance from the two distinct positions. And this method of measurement is called parallax method. Got it? So in this particular class, what we study about? We study about units, physical quantities, types of physical quantities, SI units, its characteristics, methods, other units for measurement of large distances, their relations, okay, as well as parallax methods. So thank you so much for today's class, hearing it patiently, and do one thing, try to solve some questions based on these given in your NCERT book, okay. Now you need to do what? Revise the concepts covered in this particular class, and tomorrow we will move to the second segment of this chapter, unit and measurement, okay. Any doubt you can ask, for any query you can ask at any time. Thank you so much. Have a good day, okay. Enjoy your day. Thank you.